within the vast frozen landscape of Antarctica with its associated penguins is a strange geologic oddity. At the mouth of a large glacier, a blood-red river of water gushes outwards into the surrounding valley. Because it looks like this glacier is bleeding, this overall feature is known as blood falls. This beautiful geologic wonder starkly contrasts with the coloration of the surrounding white glaciers, providing for a spectacular sight. While the coloration of blood falls was initially attributed to red algae, algae is not the actual cause of its coloration. And no, before you ask, this red color cannot be owed directly to ongoing volcanic activity despite the fact that a geologically young cinder cone can be found approximately 18 kilometers to the west-southwest. For context, blood falls can be found location 3,500 kilometers south of Dunedin, in a remote section of Antarctica. It is only 100 kilometers west of McMurdo Station, and the actively erupting Mount Erebus stratovolcano. Even from satellite you can see the staining on the landscape generated by its reddish-brown waters. So, why does it exist? The story of blood falls is quite unusual and can be traced back to approximately 3 million years ago, when the global sea level was much higher than it is today. At the time, this patch of ground was part of a fjord connected to the adjacent ocean. Eventually, the climate cooled and an ice age began 2.58 million years ago. As global sea levels dropped due to water becoming frozen in ice and glaciers, what seawater existed here became isolated by higher topography in all surrounding directions. Part of this seawater did begin to slowly evaporate, but the salt within it largely remained, causing it to become 3 times saltier than typical ocean water. Later, a large glacier which we today call Taylor Glacier advanced over this patch of seawater, trapping and burying it beneath a thick layer of ice. And, due to how salty this former seawater was, it did not freeze despite the very low temperature it experienced. During the initial advance of the Taylor Glacier, dolerite the ice carved away at iron-rich igneous rock known as dolerite, which was specifically 2.8 to 8.4% iron by weight. This dolerite was emplaced as intrusive rock less than 2 kilometers beneath the surface during a series of volcanic eruptions and igneous intrusions which occurred as the Gondwana supercontinent broke apart 180 million years ago. Eventually becoming covered oxidation by Taylor Glacier, the salty water became host to a series of extremophile bacteria which further eroded surrounding bedrock and added additional iron to the water.